So this is the 24th lecture, and let's deal with one problem based on K-map. Problem says the truth table is given for a Boolean function y. I'll just show you the truth table. This is the truth table actually. I'll just explain this. A truth table is shown, then certain parts express y as a sum of minterms and product of maxterms. Now see, it says that a truth table is given. This is a part of the problem, and this is the truth table which is given to you. 0 0 0 0 a b c d are the inputs and y is the output. Truth table is given for a Boolean function y, for this particular Boolean function y. Now express y as a sum of minterms. So see, for 0 0 0 0 it is 1, for 0 0 0 1 it is 0, and rest all the combinations are given to you. I have shown them from decimal 0 to 15 here. If I write the decimal equivalent of this is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Just see, these are decimals. Suppose this is 1010 is 10. Now look at this. First of all, first problem is that express y as a sum of minterms. Now if I express this as minterms, it is a bar, b bar, c bar, d bar. 0 is for a bar and it is 1 here, so it is in minterms. So if you see, where are the minterms? At all the positions where you have 1. If you see that you have 1 at 0, you have 1 at 2, then you have 1 at decimal equivalent 8, and you have 1 at decimal equivalent 10, then you have 1 at decimal equivalent 14, and you have 1 at decimal equivalent 15. So now I can say that at these decimal equivalent positions you have a minterm, so I can express this as a sum of minterms. First part, if you see, look at the solution here. I write look at the solution. The solution of first part, first one, solution 1. Express y as a sum of minterms. So y, which is a function of a b c d, which is given in the truth table, which is a function of a b c d, is equal to summation, sum of minterms. So what are the minterms? Wherever you have ones, those are minterms, and I find that these minterms are at 0 2 8 10 14 and 15. 0 2 8 10 14 and 15. So it is 0 2 8 10 14 and 15. If I can also write this as y as sum of minterms, or same in the canonical form, I can write this as a bar, b bar, c bar, d bar. Look at this term. It is a bar, b bar, c bar, d bar. Then this is a bar, b bar, c, d bar, plus this one, a, b bar, c bar, d bar. So I can write this in this form also. I am not writing the complete, but I can say that this, I want you to complete the answer. A, b, c, d. As a sum of minterms, it is a bar, b bar, c bar, d bar, plus this will be 1 0 0 1 0, a bar, b bar, c, d bar, and so on. I am leaving this incomplete for you. Second part of the problem, express y as a product of maxterms. Now maxterms means wherever you have these zeros. Of course, from 0 to 15, these are the minterms, means the remaining decimal terms from 0 to 15 will be maxterms only, or at least product of maxterms. So second part, I can say that this y is equal to product of, second part, express y as a product of y, of course, which is a function of a b c d. I have skipped this here, please you write here, y which is a function of a b c d, or let me write it properly, y which is a function of a B, C, D is equal to product of which max terms? Now 0 is here, so 1, 2 is already here, 3, 4, 5, 6, 7, 8 is here, 9, 10 is already here, 11, 12, 13, 14 and 15s are already there. So first part is done, second part is done. I hope this is clear to you. Next it says that minimize y by k map. Minimize y by k map. So I am rewriting this max terms and min terms here. You have min terms at 0 to 8, 10, 14, 15. 0, 2, 8, 10, 14 and 15. Alright, so let's solve it. First of all, it says minimize this by k-map. It means I need a k-map for this and I need a k-map for this. This type of problem I have done with you, but I'm reducing it with the help of k-map. So first I'll make a k-map for these min terms here. For these min terms. Of course, it's a 4 variable k-map. 4 variable. So I'll make a k-map for 4 variables. So simply what I am doing, I'll make a k-map for 4 variables here. So I'll frame a k-map for 4 variables on one side. First of all, for min terms I'm making. So 4 variable k-map, I've told you how to make it. Just divide this into 16 parts. I divide this into 16 parts. On one side, suppose it is AB, and on other side, suppose it is CD. And now I write this in min terms form. I write this as A bar B bar, or you can write 0 in terms of 0 0 0 1 also. A bar B bar. This is A bar B. This is A B, and this is A B bar. Similarly, this factor will be C bar D bar. Then this is C bar D. This is CD, and this is CD bar. And equivalently, I write the decimal equivalent of every term here. So I write this as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are the decimal equivalents. And now at what positions we have min terms? I have written 0, 2, 8, 10, 14, 15. 0, 2, 8, 10, 14 and 15. So I write these min terms here as 1 year. 0, 2, 8, 10, 14 and 15. I substitute a 1 year. Now the point is to minimize this. I want to minimize this. Now how will I minimize this? Very first thing, just see, I start from any one corner. I start from this corner. Octet is not possible. If I find that yes, one quad is possible, this folded curve is possible. This is possible here. And the expression for this, I can say that the expression for this, it is equal to, you can say that this y is equal to minimized. From here it is B bar, and from this side it is D bar. So it is B bar dot D bar plus. Let's move to the next ones. Suppose I say that you have, let's make one more term here. Suppose I say it's let's make it one 14 and 15 is here. Let's make one more, for example, let's take one 11 also. Just change the problem a little bit to make simple. I make this also 1. I make this also 1. I am changing the problem little bit just for simplicity only. So it is 1 here at 11 also. So at 11 also it is 1. Let me change the problem here. So at 11 also this will be 1. What I'll do, I'll introduce a 11 here. Please make a change. I'll introduce a 11 here, and I'll remove this 11 from here. I hope this is clear to you. So let's take one here also. so that I get one more quad. Otherwise I would have got a pair only. So I get one more quad from here. So this is another quad which I obtain. And the expression for this quad will be, from this side it is A and from this side it is C. So plus AC. I hope that this is clear to you. Plus AC. I hope this is clear. Now, what the problem says, this is the second part of it. Minimize this by K-map. Fourth part. Realize the implemented function, realize or implement the reduced function by basic gates. That is, I have to realize this or I have to implement this with the help of basic gates. Basic gates means, what do I mean by this basic gates? Realize this by basic gates. Basic gates means and, or, and not gates. These are called basic gates. And, or, and not gates. These are called the basic gates. So first part is to realize this with the help of and, or, and not gates. So I'll realize this with the help of and, or, and not gate. And how many inputs are there? A, B, C, D. I need A, B, C, D here. As I told you how to frame this, I take this one line for AND gate. Say this is A. Then this is a NOT gate here. This line represents A bar. Then I take another line for input B. This a NOT gate. This complete for B bar. Then I take another line which is for C, variable C, and I take a NOT gate from here which represents C bar, although I don't need C bar here. And then I take D. I take a variable, a line for D, and this NOT gate, this complete line is representing D bar here. Now for this particular function I need a AND gate. For this I need a AND gate, means I need B bar, D bar. So what I do, I take here. Let's see. I took an AND gate here, and the input to this AND gate is B bar, D bar. So this is B, and this complete line represents B bar. So it is, I need B bar, means here. This is B bar. This is D bar. It means this is B bar here, and this is D bar. Second, I need AC. Another AND gate where the input should be A and C. It is A from this side. I show this. Of course, this is representing A, and this is line for C. So I show it here. This is C. Now this is done. This is done. This will give me B bar, D bar. Output of this will give me AC. I need addition of these, means I need a OR gate here. So what I give? These two are given to a OR gate. OR gate. And this is my final expression Y. So I hope this is clear to you. Now second part says implement the reduced function by basic gates that I have done by NAND gate only. When it says that by NAND gates only, means I don't have to use any other gate, but I have to use NAND gate only. So what I do, that for this I need, for NAND gate, as I told you, that the expression should be in SOAP form. So this is already in SOAP form. So I'll express this, I'll reduce this by NAND gate only. So in order to reduce this by NAND gate, again I take 4 lines for 4 inputs. So I started from here. Say this is A. And of course, in spite of NOT gate, I'll use a NAND gate here. In spite of this NOT gate, I am using a NAND gate. Again, B. This input B. And I'll use a NAND gate in order to make a NOT gate. Then I'll take C. Say this is input C. Again I take a NAND gate acting as a NOT gate, and further I take input D. and this is again NAND gate. I told you how to make NAND gate as a NOT gate, you sort it. Now same thing, in spite of this I'll use a NAND gate. Here I'll use a NAND gate. In spite of this also I'll use a NAND gate. Or I can say for this expression you need a NAND gate, for this expression you need a NAND gate. And overall it is given to another NAND gate. And this is a final output Y. Now to this NAND gate B bar D bar. This is B bar. It is same figure. In spite of using these gates, I am using NAND gates because this is in SOAP form. B bar, this is D bar, then AC. This is A, and this line, it represents C. And this is my final expression Y. So I hope that this part is also done. Basic gates, NAND gate. Next it says realize or implement the reduced function by NOR gates. Now the function which I have obtained is in SOAP form, but it says that realize this by NOR gates only. I told you for a function to be implemented by NOR gate, try to bring it in the POS form or simplified POS form. Now how to obtain the POS form? I can get the simplified POS form by solving this expression. So I'll frame a K-map for this. I'll frame a K-map for these max terms. So I'm framing a K-map for these max terms, and then I'll realize this with the help of NOR gates only. So first let me frame a K-map for 4 variable and for max term, for the purpose of max term. So this is the K-map. 16 cells. I divide this into 16 cells. Simple. On one side you have A plus B, or AB, you can write AB also, and this is C plus D on this side. Just the opposite of this, it will be A plus B, 0 0 A plus B, 0 1 A plus B bar, 1 1 A bar plus B bar. This is A bar plus B bar, and this is A bar plus B. Similarly, this will be C bar, not C bar, C plus D, C plus D bar, C bar plus D bar, and here it will be C bar plus D. I hope that this is clear to you. Decimal equivalent remains same as I told you. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now I substitute a 0. I substitute a 0 on these positions. 1, 3, 4, 5, 6. It is. I substitute a 0 at, let me use some other color, at 1, 3, 4, 5, 6, 7, 9, 12, 13. 7, 9, 12 and 13, because rest was used for min terms. 0, 2, this and yes, it was used for min terms. Now I'll have to do the grouping of this. What is the grouping of this? I look for the biggest group. Octet is not possible, so I make this group first. I make this particular group, and the value of, I'm not writing 1.2.3.4. So y, which is a function of ABC, the final expression for this will be simply, here it will be A plus B bar from this side plus 0 from this side. Complete column is covered, so it is A plus B bar. I hope that this is clear to you. Second, For the remaining zeros, the biggest group which is possible, I am starting from here, is a quad here. Another quad is possible, and the value of this quad will be c plus d bar. So it is c plus d bar. Of course, from this side it will be 0, c plus d bar plus 0. Now remaining this one is here. I'll not make a pair. I told you try to make the biggest group. So the biggest group which I make from here is third one is this. I'm showing with some other. The third group is this one. This, and this much. And the value of this from this side, what is common? A, and from this side d bar. So it is a plus d bar. A plus d bar. This much dot. What is remaining? This is remaining. I make another quad from here. This quad. And the value of this quad, if you see, from this side it is b bar, which is common, and from this side it is c common. So b bar plus c dot, I'm writing here, dot b bar plus c, because I want to make a figure here. This is in continuation. I can say I'm rewriting this, a plus b bar dot c plus d bar dot a plus d bar dot b bar plus c. I hope this is clear to you. Now it is asked to implement this by NOR gates only. I am solving this actually. Implement or realize the reduced function by NOR gates only. So I had to reduce this function or this function. First of all into POS form. So I have reduced this into POS form, and this is the corresponding POS form of this. So I need a NOR gate for this, NOR gate for this, NOR gate for this, NOR gate for this, and overall it is given to a common NOR gate. So what I do, first of all, as I did in the previous case, I need A, B, C, D. So I make a separate lines for A, B, C, D. Say this is A. Of course, a line here, I need a NOT gate, but with the help of NOR gate. So I use a NOR gate here. I short this, which is acting as a NOT gate. Then this is line for input B, and again I use a NOR gate here, which is acting as a NOT gate. Then another line for input C, this is input C, another NOT gate here, but with the help of NOR gate only. I take this as I short this, and last line, complete line for input D, and a NOR gate here. So these are the 4 inputs along with its complements here. I hope. So first is A plus B bar. I need a NOR gate here. Let's see. A NOR gate is here. And the input to first NOR gate, I need 4 NOR gates here. 2 input NOR gates. A plus B bar. So this is A. This is A. And this is B bar. So this is here A plus B bar. Next is C plus D bar, another NOR gate for this function, where the input is C and D bar. C and D bar. This is D bar. Then another NOR gate, and the input to another NOR gate is A and D bar. So this is A from here, and this is D bar. And finally one more NOR gate, where the input is B bar and C. So this is B bar. This complete line is for B bar. So this is B bar, and this line is for C. And overall it is to be given to, and finally one more NOR gate. I'm showing it here. This is your final expression y, and all these inputs are given to this. I hope this is clear to you. So this is the final figure. So I hope that this is clear to you, that how to realize, how to simplify a K-map and realize it with the help of either basic gates or by NAND gates or by NOR gates. The point is to simplify this with the help of K-map. If it is asked by NAND gates, then express it in SOAP form. If it is in by NOR gates, then try to express the expression in POS form. I hope that this is clear to you.